This is the video for lesson 4.8, in which we are going to be talking about isosceles and equilateral triangles and the different theorems that go along with those two types of triangles. And for the vocabulary, please make sure you're using a pencil, and I would like you to fill in the information about isosceles triangles. Isosceles triangles have exactly two congruent sides, and those two congruent sides are called legs. The angle formed by the legs is called the vertex angle. The third side is called the base. The two angles that are adjacent to the base are called base angles. And you will need to be able to label and mark an isosceles triangle on a quiz. So you're going to want to know that these are called the base angles down at the bottom where we have the congruent legs. And the bottom itself is called the base. And then, of course, the top is called the vertex angle, or the angle where the two legs meet is called the vertex angle. So I'm going to ask you to label an isosceles triangle with the appropriate terms on a quiz coming up. Theorem 4.7 is the base angles theorem. So it says if two sides of a triangle are congruent, then the angles opposite them are congruent. So you can imagine an isosceles triangle, right? We already know it's called isosceles because it has two sides congruent. Then the angles opposite each of those sides are congruent. Theorem 4.8 says the converse of that, if two angles of a triangle are congruent. So if I have a triangle and two angles are marked congruent, then the opposite sides are congruent. So either way, we know that if the base angles are congruent, then the legs are congruent. If the legs are congruent, then the base angles are congruent. And then we have a corollary to the base angles theorem that says if a triangle is equiangular, where all the angles are the same measure, right, all of them, so each angle is going to be equal to 60 degrees, then it is also equilateral. So therefore, all the sides are the same length. Now, in the next statement, corollary to the converse, then it says if the triangle is equilateral, then it is also equiangular. So if I had a triangle that was marked with all sides congruent, then we would know that all of the angles are congruent as well. So it goes either way. There's a converse, and we know that converse just means switch the information, switch the hypothesis and the conclusion. So let's go ahead and take a look at a few of the examples that we have on our note sheet so we can get used to using these different theorems and rules with isosceles and equilateral triangles. So in the diagram, it says here that RT is congruent to ST. We need to name the two congruent angles. Well, in the theorem that we just read, it said if the sides are congruent, then the opposite angle to that one is congruent. Okay, so that means then that angle R is congruent to angle S. And it's because if two sides are congruent, then the opposite angles are congruent. Okay, and that's because this is an isosceles triangle, and I know it looks upside down right here, but these would be called the base angles, right? Angles R and S are the base angles, according to what we were just looking at in the vocabulary section. So for example 2, it says to find the length of AB and the length of AC in the triangle below. The first thing I'd like you to notice is that all of the angles, angle A, angle B, and angle C, are congruent. So because they are congruent, all of the sides are also congruent. Remember, we read that. So if this side is 11, then this side is 11, and this side is 11. All right, so angle B is 11, side length AB is 11. AC is also 11, and the reason for that is if all angles are congruent, then all sides are congruent. All right, so if it's equiangular, it's equilateral. If it's equilateral, it's equiangular. All right, guys, for the on your own practice section, I want you to find the length of WY, which is this side right here. And we'd also like you to find the measure of angle WXY. And that's this angle right here. All right, on the back side we have example number 3. These problems, example 3 and 4, are a little bit more challenging, and we do need to look carefully at each diagram. So it says here in the diagram that the measure of angle DEF is 90 degrees. Okay, this one. And we need to find the value of X, this is an angle measure, and the length of Y, which is this whole side called DF. So to get started with my solution of X and Y, I first want to state that angle E is congruent to angle F, okay? And that means that side EG is equal to 3. So side EG is equal to 3 because notice that this side over here is also equal to 3. So, and that, I mean, I'm just writing this down because I wanted you to notice that triangle EGF is isosceles. Okay, so take a look at triangle EGF. That's this one here. That one is isosceles, and we know that because the angle here and the angle here are congruent. We had that marked on the diagram. And then because those are congruent, we have a side that's 3 and another side that's 3. So if we look even further now, if this side is 3 and this side has a tick mark and this side has a tick mark, then that means this side of the equilateral triangle is 3 as well as this one. And I know then that that the amount for X is 60 degrees, because if I look at this triangle, DEG, okay, it had those tick marks, right? And therefore, if those are all the same length, then all of the angles are the same measure as well. All right, so X is 60 degrees because triangle DGE is equilateral. So if it's equilateral, then it is also equiangular. Okay, I'm trying to fit a lot of information in this little space. Now, I also already mentioned that this side, DG, was 3 because it had a tick mark here that the EG was 3. Okay, so Y is going to be 6. The reason Y is 6 is because the side DG is equal to 3 and GF is equal to 3. And all I did was I added that up because Y is this whole side called DF. And our last example problem, we're still using the ideas from the front, which have to do with, isosceles triangles having two base angles that are congruent, and all sides of an equilateral triangle being congruent, therefore the angles being congruent. All right, so in example 4, we are going to skip part C, and the only reason is because I want to keep this video short. So to keep the video brief, we're going to skip part C because there's quite a bit more information to do in part C. But we are going to do parts A and B. It says, what congruence postulate can you use to prove that triangle ABC and triangle AED are congruent? Well, I'm going to outline those two triangles to show. It's going to be this triangle and this triangle. Okay, you should still be able to see the tick marks there. And because the two sides are congruent of the large outside triangle, maybe you already noticed this, but there are 4 triangles there. So I want to just highlight that these two are congruent sides. And that means that this angle is congruent to this angle, because if you look at the very large triangle ABE, we can see that that's an isosceles triangle. So we have a side and we have an angle congruent there. And then we also have this little portion here congruent to this little portion here. So in my ADE triangle, I have 2 sides and an angle, and in my ABC triangle, I have 2 sides and an angle congruent. So that's what I'm saying, is I can use SAS to prove that they are congruent, because AB is congruent to AE. Angle B is congruent to angle E, and BC is congruent to DE. And the last part that I'm going to do with you here is going to be part B of example 4. Explain why triangle ACD is equiangular. Well, if these two triangles are congruent, so we said that a triangle ABC is congruent to triangle ADE. So if that's the case, then this side here, DA, has got to be congruent to CA, because remember, the corresponding parts of each triangle are congruent. Now, if those two sides are congruent, then that means this angle here has to be 60 degrees. And if these two, both of them are 60, then obviously that one at the top is 60. So we have an equiangular triangle because the two legs are congruent, and therefore the two base angles are congruent. So we want to say that angle ACD is congruent to angle ADC, since side AC is congruent to side AD. And that means that, and that's their little symbol for therefore, angle CAD is also 60 degrees. Okay, and so therefore we know that the triangle is equiangular because we had two base angles that are 60, and therefore the last one also has to be 60 degrees. So I hope that this video walked you through the different ideas of isosceles triangles as well as equiangular triangles that end up being equilateral as well. There will be some new signs posted in the classroom tomorrow, and go ahead and put an X through this portion of the video, or sorry, of your notes, so that we know we're going to skip that part. And down near the bottom, I'd like you to take a look at the on your own problems. So you're going to do number 3, which says find the values of x and y. Here's x, and y is this entire length here. Maybe go back to a previous problem that I did and check it out and see if you can figure out what the value of x is and the value of y. Make sure you include an explanation. And then the last problem says show that ABD, that's triangle ABD, is congruent to triangle AEC using side, side, side. Okay, so you're going back up to the diagram in example 4 to take a look at how you can prove those two triangles congruent using side, side, side. All right, I will take some questions in class, and just make sure you make an effort on these on your own problems. Thank you.